Hi everyone, this video is on the mixed exercise 9 question 12. We have the curve with the equation y is equal to e to the x squared cos x, and in part A we want to show that the turning points on C occur when tan x is equal to 2. So what this means is that we first need to remember, if we want to find the turning points of a curve, we first need to differentiate that and then set the equation of the first derivative equal to 0, and the solutions of that equation are going to be the x coordinates of the turning points. Now in this case, the task is basically finding the first derivative and setting that equal to 0. Then hopefully, if everything is done correctly, then we should get something like this. But let's do that first. So we want to differentiate this. It's a product rule. We have e to the x as our first function and cos x as the second function. So I'm going to write down the first function times the derivative of the second one. Cos x differentiates to minus sine x. Plus, now the derivative of the first function times the second function. So e to the 2x differentiates to 2e to the 2x because we differentiate the power, and that comes down as the coefficient of the function, times the second function, which is cos x. And in the next step, we can simplify and then factorize this to have in a nicer form. So actually, I'm just going to factorize right now. So e to the 2x is my factor, and then it's going to be 2 cos x minus sine x. Right. Now we want to find the turning points, so we need to solve dy by dx is equal to 0. Actually, we don't need to find the turning points in this question because it's just asking that show that if you want to find the turning points, then this we can use this equation basically. So we have e to the 2x times 2 cos x minus sine x equal to 0. There are two cases if you want to solve this equation. Either e to the 2x is equal to 0, or 2 cos x minus sine x is equal to 0. But the problem with the first equation is that e to the 2x can't be 0, so this doesn't have any solutions. There is no value of x that if you have e to the power of that times 2 and getting 0, so there does not exist such value for x. That's why there is no solution. But we can solve the second equation. So let's rearrange that first. 2 cos x is equal to sine x. And let's divide both sides by cos x, because remember that here we want to get to this form, which is tan x is equal to 2. So we need to make some changes such that we are going to have tan on one side of the equation. And the best thing we can do is dividing both sides by cos x to get tan x on the right hand side. So as a result of that, we are going to have 2 is equal to sine x over cos x, which is basically equal to tan x. And that's equal to. And this is exactly what we wanted to show. And that's why I mentioned earlier, there is no need in finding the turning points in this question. So it was all about just showing that this is the form that will help you to find the turning points. Okay, now for part B, it says find an equation of the tangent to C at the point where x is equal to 0. Okay, so if you want to find the equation of the tangent, we need two different things. One of them is the coordinate of the points that the tangent passes through. In this case, we already have the x coordinate. We just need to find the y coordinate of that point. So we can find that by substituting x into the equation of the curve, which is y is equal to e to the 2x times cos x. So if you substitute 0 into that, we are going to have e to the 0 times cos 0, which is just 1. So the point has coordinates, let's call that point P, 0, 1. That's the first thing. For the second thing, we need to have the gradient of the tangent line before we can find the equation of that. And in order to find the gradient of the tangent line, we just need to substitute the x coordinate of the given point into the equation of dy by dx, because that allows us to find the gradient at that point. So we can write when x is equal to 0, then let's see what is the value of dy by dx. So substituting into this equation, we'll have e to the power of 0 times 2 cos 0. So remember that cos 0 is just 1 minus sine 0. So sine 0 is 0, cos 0 is 1. So 1 times 2 is 2, and then e to the 0 is also 1. So divided by dx is equal to 2. That's the gradient. We have the point. Now we can find the equation of the tangent, which can be found by the equation y minus y0 is equal to m times x minus x0. So it's just now the matter of substitution. Y minus y0, which is 1, and then m, which is the gradient, times x minus x0. Yeah, so now if you rearrange this, we are going to get y is equal to 2x plus 1, and this is the equation of the tangent. Okay, that's it for this video. Thank you for watching.